Hi guys, here's another vector addition problem. This one I'll use law of sines, law of cosines, so a little more complicated. It says a boat travels due east at a velocity of 6.67 meters per second. The river is flowing at 8 meters per second at an angle of 83.2 degrees above the horizontal. What is the boat's velocity relative to the shore? So when we are finding relative velocity, in this particular case, we're just adding the boat's velocity to the river's velocity. So let's start with a picture. So the boat's velocity is due east. So this is the velocity of the boat. It is 6.67 meters per second. We then have the velocity of the river, which is inclined at a very steep angle at 83.2 degrees. So this angle here is 83.2 degrees. And the velocity of the boat is, the velocity of the river is 8 meters per second. Now, the resultant is drawn from where I start to where I finish. So this is the relative velocity. And this is what I want. I need both this magnitude and the direction here. The direction would be the angle with respect to the horizontal. So I need to break into this triangle. I know that this angle here is 180 degrees. So I can get at this angle very easily. This is 180 minus 83.2. So that is 96.8 degrees. From there, I have the side across from that, the thing I need, and the two other sides. So this screams law of cosines. The law of cosines is c squared equals a squared plus b squared minus 2ab cosine of c. So I will plug everything in. So v relative squared equals VR squared plus VB squared minus 2 VR VB cosine of C. And from there, let's get some numbers. So V relative is going to be the square root of 8 squared plus 6.67 squared minus 2 times 8 times 6.67 times the cosine of 96.8. Punch that into our calculator, and we get roughly 11 meters per second here. So this is the magnitude. Now, the direction is given by this angle here. In order to get that angle, guys, we now know relative velocity is 11. So we have all three sides. We have one angle. We can easily find this angle, which I'll call theta here, using law of sines. So law of sines is sine A over A equals sine B over B equals sine C over C. So in our case, we are going to start with our given, which is sine of 96.8 over 11 equals the angle that we need, so that is sine theta, over 8. So let's do some math here. So sine theta is going to be 8 sine of 96.8 over 11. All right, in doing so, we've got sine of theta equals 0.722. Taking sine inverse. We get theta is equal to 46.23 degrees. And looking at our picture, that is going to be north of east. So our relative velocity as a vector is going to be 11 meters per second at an angle of 46.23 degrees north of east.